Of me streaming algorithmic solutions in JavaScript. My name is Paul Kronius. Again, I'm a front-end developer at Hilton, and I'm just frankly looking to become a better developer and also kind of share some insight into how we solve algorithms today. So yesterday, which unfortunately didn't get archived to YouTube because I am still learning how connections work in Twitch, we worked on binary search, which is a very common algorithm that I have used in real life personally in my previous job when I used to work in semiconductors. Binary search is a quite effective way to basically try to find a specific value in a data set using a concept called divide and conquer, which essentially tries to have the space every single time you do an iteration, or in other words, cut the problem in half. So as we discussed last time, that would result in a big O notation of O log of n, which basically means, yes, it's going in half. Now today, we're going to look at Leetcode problem 278, which is first bad version. This one I don't remember as well as binary search, so I think this one might be slightly more embarrassing as I try to grok out what the answer is, but that's okay. We're here to learn together. I'm learning, and hopefully you'll have some fun as you participate as well, or watch this, I guess, in the near future. So let's go ahead and get started. So 278, first bad version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails to quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Yeah, as a developer, definitely seen this happen where you push a release into the develop chain and then you realize, oh no, this is not correct. And then you often have to have the conversation of, well, do we revert the pull request and then try to fix it, or do we hotfix it with a new patch? So yeah, this happens a lot in real life, especially if you're a fellow developer. Let's go ahead and continue, shall we? Suppose you have n versions, 1, 2, ... comma, n. So basically the ... is just representing a series, which you might have seen in your mathematics classes, like especially when talking about summations. And you want to find out the first bad one, which causes all the following ones to be bad. So we're given an API in this case, and really the way to think about this is just a black box function. And what we mean by what we say in black box in this case is that we don't really know how it works. All we know is that given we give it some input or some kind of information, it's going to give us back something. That's called black boxing, and it's a powerful tool in software called abstraction because it allows you to do things without actually having to know every single bit of how it's done. This kind of goes more into a discussion of what's called declarative versus imperative programming, which we'll certainly talk about in the future. But the idea is use something for what it is rather than use something for how it works. Now, there are cases you definitely want to know whether you're using, you want to know more about the details versus what the result is. But at least for me personally, what I'd like to do is abstract stuff into functions, or basically reusable pieces of code with names that say what it does. So like in this case, is bad version, I can just know by looking at the function that this is going to tell me, if I put a version number in, it's going to tell me if it's good or bad. I don't need to know how it knows, I just know it's going to give me a good or bad answer. And that's powerful, and a lot of open source software that's kind of developed over the past couple of decades has gone on this concept that you don't need to know how the thing actually works, you just know that it will do this for you. So anyways, long story short, so let's keep going. You are given an API bool is bad version. So that's the API, which returns whether version is bad. Implement a function to find the first bad version. And as an ask, as an optimization, they say you should minimize the number of API calls as much as possible. Makes sense, right? Because like with any API, you start to talk about things like rate limiting and the cost of bandwidth. So you only want to hit what's called an endpoint, which is what serves an API. You only want to hit it as little as you need to as a developer, and also from a business perspective, because it takes more time, so your user's waiting, it costs more money because of the bandwidth, and it's just not very efficient, right? Like as developers, we talk about concepts such as dry and wet. Now I'm not saying, I'm not one of those super dry people, clean code, I'm okay with a little wet, but the idea is that try to reduce as much of the duplication as possible and try to get as optimal as possible, because that'll give you space not only to grow your code and extend it as you add more features, but then make sure you're not boggled down with tech debt when you have to go back and actually refactor and go, well, if I call it 10 times, then I have space for something else. So long story short, Just makes sense, right? Like just use your resources the amount you need to, don't waste your resources. All right, so let's look. So we have an example 1 here. So if we look at example 1, it says input n5 bad is 4. So in this case, n represents the number of versions or the number of versions of your software, and bad represents what's supposed to be the bad version. So that's kind of the answer, right? So what we see is we call bad version with 3, and it says it's not bad. So that means we're good to go, right? We then call is bad version with 5, and we get true. So that tells us, okay, at least version 5 is bad. At this point, we now know that the version that goes from good to bad, basically the commit, colloquially, the commit that caused us to poison our versioning is somewhere between 3 and 5. So in this case, well, 3 and 5. So in this case, there's only one version, because again, these are integer whole numbers similar to the binary search. There's only one version between those two, and it's 4. So we call 4, and what we see is that it is also a bad version. Well, from inspection, don't even think about code. Just look at the output of the explanation. We know that from version 3 to version 4, we went from good to bad. So therefore, we know 4 is the bad version. So that's what they're trying to get us to solve here, and we're solving it by calling this is bad version API. Example 2, if the length is 1 and 1 is, or sorry, the length, I apologize. If there's only one version and the version is bad, then we know that essentially, yeah, that's got to be the bad version. So that's kind of more of a base case, but what they're trying to tell us is it's possible that we developed a feature and we developed it wrong in the first place. So those are kind of the 2 cases. Okay, finally, let's go ahead and look at the constraints. The constraints of this problem are that basically the bad version is somewhere between 1 and 2 to the 31 minus 1, which is roughly, I believe that's the safe integer range. It might be 2 to the 32, but that should be within the safe integer range of JavaScript, so we're not going to have to worry about overflows in this case. And it also tells us that we're always going to have a bad version. We're not going to have to handle the base case where it's good, which makes sense because if the last version is good, the only way to check to make sure all other if the last version is good, then there's nothing to test, right? But that can be easily solved. Like again, you can basically say check the last version, say is the last version good? And if the answer is yes, then there's no work to do, right? But we're not going to code this in this case because the constraint does not say we need to. All right, so let's get started. So the boilerplate, or basically the setup code they gave us in this case, is a function called solution, and it takes is bad version, which is the API. And remember, in JavaScript, almost everything with the exception of 2 things, and please don't quiz me on JavaScript on this. I know the answer to this, I want to make sure I don't say something that's false, but essentially almost everything in JavaScript is actually an object. So you can pass objects as args all over the place in JavaScript. So an API of is bad version is really no different than an object, because a function is also an object, so you can pass an object. So we get this, and then basically what this function does is it's going to return a function, and that function is probably going to need to consume this is bad version, right? So the idea is this function will run, and it will keep running until more or less we decide that we have determined what is the first version that has gone bad. So this is almost recursive-ish in my opinion. So it is kind of, but where the recursion is, but it's kind of a little bit different than binary search, right? Because like at the end of the day, we're kind of having the problem every time, right? Because we're saying, is this one? No. Is it this one? No. But this time, what we're looking for is basically I would say a flip in polarity. But instead of polarity, it's like turning a light switch on and off. We're waiting to see when it goes from false to true. We want to know that, back in the electrical engineering days, I would call it an edge. But we're basically looking for that transition, and that's the target in this case. It's not a specific number. It's the change in state from the API that we're trying to hunt down this time. So, like I alluded to earlier, I am not as familiar with this problem. It's been a while since I've worked it. Might be a little embarrassing. I'm not going to look as put together as yesterday, but that's okay. Let's go through it and see if we can figure out what to do. All right. So the first thing that we have to do, and every time we run an iteration, is we need to figure out, hey, is it good or bad, right? Because like if we don't know if it's good or bad, we don't know what to do in this case. So I'm going to just define a const is bad. So, and the goal of this is basically to get the output of this API is bad version for this, what do we call it? For this version in the list of versions, right? So I will know after this iteration whether it's bad. Okay, so now what would be, so there's two scenarios that we need to handle. Well, maybe three, but there's two I can think of right away. First scenario is, and let's just give ourselves a little pseudocode to scenario 1. And for the viewers, let me blow this up one version so it's a little bit easier for y'all to read. I'm sorry, I apologize. I should have done that at the start. So if we look at this now, is bad version. So scenario 1 is bad is true, or in other words, it's a bad version. So if it's a bad version, then we know. So let's think about this out loud together. All right. So if we have a bad version, we know it's bad, but we don't know if it's the first bad version in the line, right? We only, at this point, we only know that somewhere before. Okay, we have two cases here. Either A, the version before this is also bad, so this is not the one we want, or B, the version before this is good, in which case we have found the first bad version and we can simply return this version n from the function, which is what it's expecting in this case. So a very, I'm going to call, what's the word for it? Naive solution to this would be, and this is not efficient per se, and there's probably a better way to do it, like kind of using more divide and conquer like we previously discussed. Oh, I'm so sorry. Hey, Wibs. I just gave you a nickname. All right, let me see if I can, that's a good question. I don't know how to shift the window. Oh, I see now. Maybe if I do this, and let me do, there we go. That might be a little better, right? Probably. I can see it now in the video. All right, yeah, I hear you. I can also shift the window. Let's shift the window a little bit. But at least I think now there's more space to kind of see what's going on. Okay, so let's see. All right, so where were we? Okay, so first scenario, it's bad, right? So, thanks, Ben. All right, so in this case, if it's bad, the naive thing to do in this case, if we're going from a naive solution perspective, would be to call is bad version again for one version before it. So in this case, however, though, I think we could actually do a little better than that. And I think what we instead need to do is recall the entire function recursively with basically the version back by one. But the problem then, and this is what I'm trying to remember, is we need some sort of state because we need to understand in the case there's an inversion, right? Like, so basically when it flips to good to bad, so we need to know the current one and the previous one are either both still bad, or the current one and then the previous one goes from good or goes from bad to good. So that's what I need to think about a second. How would we programmatically know that? Yeah, you see I'm a little rusty right now. That's why I'm here. I'm definitely a little rusty. Trying to think through how we would end up solving this. So what I could do, let's go with something naive. I mean, the goal is not to basically be perfect when you're working these. You kind of come up with a working solution and then you work to something better if you think of something better. So in this case, what I could do is say if is bad. So basically it is a bad version. And if I call, but see, this doesn't really, I mean, because this is almost a, this is almost an iterative solution, right? Because we're kind of going through and we're not recalling this function. Let's think about this a second. Wibble, you got any advice on how we would recursively call this function? I'm calling a friend here. I'm trying to think what would be potentially a good way to call this again in a way that I know that basically we flipped versions. All right. That's not true, man. That's not true at all. I've seen what you wrote. You wrote some good stuff, man. Come on. All right, so let's think about it. You know what? I'm not going to worry about figuring out the way I should do it. Let's just get something working first with at least one test case, right? So let's see. If it's bad, and if I call isBad version with one version back, and it's also bad, then in this case, what I would expect to have to do is I would then need to recall. What I think I need to do in this case is I need to basically call this function again recursively, but just basically with one version back. So how would I do that though? Because this is the mama function. The mama function is the anonymous function, or sorry, not the anonymous, the solution function. So then how do I, at this point, do I recursively call this function? I feel like, you know, I almost want to do this iteratively first and then figure out the recursive version. So since I'm not comfortable, let's do it iteratively first. Because honestly, I can't remember how to do it recursively. And then what we can do is we can go look at a hint together and kind of see what we should have done here. All right, so if we look at this, so let's just start out. So in this case, but we can't do that because it's running this and passing the number. It's oh, I see why. It's closures. Oh. This is why I need to practice, everyone. Okay, so in this case, since we're using closures and we're passing a function into a function, I have to keep this. Yes, that's correct. The issue in this case, it's not an issue. The way this problem is designed, it's closures. So the test runner is going to pass in just a number right here. So I can't do it in an iterative way because I don't think the test runner is going to be able to, or in other words, the shape of this function is not going to match with how the test stand works. So unfortunately, I won't be able to pass the grader. So I have to keep it in this format. But yes, that's correct. The idea would be, I could even do something like binary search, where I would find basic, well, no, binary search won't work because they're not unique. So yeah, the naive approach would be to, I guess, maybe something like two-pointer. I could also consider something like two-pointer where basically I wait until the left pointer is good and the right pointer is bad, and they're within one version of each other. That would be potentially a two-pointer solution, but I don't think that's necessarily what they're trying to go for here. I need a hint. But yeah, to your question, I know what I'm supposed to do here. I like from a logic perspective, I know what's actually tripping me up right now is the JavaScript, which is unfortunate. Okay, let me see if I can think one more moment about this. All right, so let me see, because I don't want to look at a hint yet. I want to think about this for about another minute or two, and then we can start looking at some of the discussions to get a hint, and then kind of talk through what the solution would have been. So isBad version. So we pass. So we have a function that takes in isBad version. Yeah. Recursion's good. I will say, I mean, there's definitely a lot of cases. I think I only have used recursion in production code twice. Most of my solutions tend to be, most of my solutions tend to be iterative, which is essentially like you were just discussing, just stepping one version and making sure it's correct. That's called an iterative approach, versus recursive is where you get information and then you basically pass it. You basically take the information. Oh, that's more called dynamic programming, so I should probably push that to the side. That's something slightly different. But yeah, the idea in iterative is like you kind of loop through all the elements and you find the answer. So yeah, that's not how this one is set up, unfortunately. So gotta think real quick. You know what? I think I know. Okay. I think I know what this is supposed to. Okay, I think I get it. Okay, so if we look, let's look at this again. So what it's saying is, if you look here, this is called, this is JSDoc. So this is kind of like functional documentation. So what it's saying is this function takes a parameter called isBadVersion. That's the API that tells you whether the version of the software is good or bad. This, it's saying, is also supposed to return a function. So that's a hint. It's basically saying for its return signature, what it's expecting to see is that you return a function, which makes sense because you keep running the function until you get the answer. So yeah, that's the recursion. It's basically saying to call itself again. And that makes sense, right? Because if you look at the return statement here, it's saying return function, so that would match what it's arguing, no pun intended. Ah, this one's frustrating. It's something really simple, I just can't think of what it's supposed to be. If it's bad, so if it's bad, all right, so what I would expect to happen in this case is if it's bad and the previous version is bad, we would basically then want to check. Let me just kind of type out what I would think would happen here. We would then call is bad version on the previous version, right? But we actually need to call the function. But the second case is if it's not bad, so else if, in this case, because it's the second condition would be, let me come here, so basically the second case is if it's bad and if the current version is bad, but the previous version, with the exclamation in this case means not, if the previous version is not bad. So if the current version is bad and the previous version is not bad, then we know this is the first version that's bad, in which case we would return n. So this is basically the scenario where we've actually found the bad version. So this is the easy part, right? This makes sense to me. This part is scenario 1 and this is scenario 2. But this first case is what's throwing me off right now. If it's bad and the previous version isn't bad, how do I recall this function? Just keep thinking about it a second. Because the wrapper function solution just takes the API of is bad version, so that's not going to help us. So I don't want to call. I'm almost wondering. I don't know if this is the best thing to do, but maybe what we need to do here is actually define another function and call the function within the function. So we got to go 3 functions deep. So let's do that actually. Let's just write a function. Let's just write in the function. So this function would be called const. It's called check next version, and this function is going to take a version. Okay. And don't be thrown off, I'm just using arrow syntax right now rather than functional syntax. The differences have to do with something called binding of the this. If you've ever heard of this, especially like if you come from a Java background or you've kind of done more imperative like non-automatic garbage collected languages like C++ or Java, but it's just another way of writing a function. So what this is going to do is this is going to run. See, I feel like this is doing exactly what the bottom function is doing, because what we're doing here is check next version is going to take, it's going to basically say is bad version n. So yeah, it's doing the same thing. So how do I call this function again? Oh, frustrating. So if bad and bad, the previous version is bad. All right, let's do this. Let's do this wibble. Let's try this. Let's create a function. I'm going to take all this code I just wrote and I'm going to put it here. All right, and then what I'm going to do is I am going to, okay, you know what? Maybe, I think we actually might be onto something here. All right, so let's think about what's going on here. So what we want to do is this function is like a loop. It's like a for loop, like you were just discussing about iterative, right? So this is going to be responsible for kind of churning through the versions and figuring out what's going on. This is going to be the thing that we call depending on what's going on. So in this case, what we want to check, so we want to recall, we basically want to call this method. Yeah, I got it. Okay, I think I got it. All right, so here's what we're going to do. So here's how it's going to work. Here's the function. So check is current version first bad is going to take a version, and the first thing we're going to do is check if it is a bad version. If it's a bad version and the previous version is also bad, we're going to recursively call this again. We're going to call it again, and we're going to run it again. And we're going to keep running it until the current version is bad, but the previous version is not. And when that happens, at that point, we will return the version. So then all I have to do here in this case is do this. So what this should do is this will pass n into this function, and this will keep running until eventually I get the version I'm expecting. And actually, I think that code works. Now, it's not performant. I don't think it's as performant as it should be, but I actually think this might work. All right, so let's do kind of a test case to see what would happen here. And what we can actually do is use this example and kind of test to see whether the code makes sense. So let's use example 1 as a test case. So 5 versions and the bad version is 4. So if we step into our function, basically everything starts right here. So we pass 5. So version 5 gets passed into check is current version first bad, 5. So we check is 5 bad? And we know that the answer is yes, because at least version 4 is bad, so that means version 5 is still bad. So good, it is bad. So scenario 1 is bad, true. So we fall into scenario 1, is bad is true, and we now check to see is the previous version also bad. Since we know the bad version is 4, version 5 and version 4 are bad, so this entire condition is logically true. So now, and actually I could, yeah, we'll just go back 1 in this case. I think this is the right way to do it. We're then going to call this function again 1 version less. So this goes from 5 to 4. So now this function calls with version 4. So here we go. Is version 4 bad? Yes, it is, because again, the example says version 4 is bad. Now let's step into the scenario, because it's bad. Is it bad? And is the previous version bad? Well, in this case, we know that version 3 is good, because the first bad version was 4. So we fall into scenario 2 in this case, which actually, now that I think about this, this is just an else, right? Because if it's not this, then it has to be the case that we found the bad version. So this actually simplifies to just a simple else statement. So if this is not true, then it must be the first bad version, in which case we return it. So I'm confident enough to at least try 1 run. Oops, what did we mess? Unexpected token dot. Okay, so I have a small, it looks like I accidentally hit the period key. 1 second. What line is it on? 32. So if we go to line 32, yeah, right there. All right, let's run that again. All right, output is undefined. So why? Oh. So whenever you're returning a function from a function, what I just returned was nothing, because I just said run the function, but that actually doesn't return anything. I need to return the function because I need to return the output of this higher level function. So now if I run this again, still undefined. Okay, so maybe that means we have a logic bug. Let's think through this for a second to see what's going on. All right, I think the best thing to do here is let's go ahead and do a console log. So we can, this is just the way JavaScript logs that information to the user. And what we're gonna ask is bad, and then what we're gonna do, and then we'll say, let's just say version, and then we'll do a variable for what would be called is bad version, and we'll call this both bad. All right, and then what we're gonna do is pass the arguments. In this case, it'll be is bad n, and then we could extract this to a variable, but in this case, since it's just debug code and I'm being a little lazy, I'm just gonna paste this in, and then we're gonna hit run code. So we should see some console logs. Okay, is bad version, both bad, true, 5, true, which is what we expect, right? Is bad, for false, and actually that's correct. So actually that is in fact what I expect. It actually stopped iterating at step 4, version 4. So now the question is, why are we not getting a value here? Huh. All right, let's do another trick I like to do. Let's go ahead and assign this to a variable. Let's see if this is actually returning us this value. And then, just to be complete, we're going to have this. Yeah, let's. Yeah, let's just have it return temp in this case. All right, cool. So let's run this. Yeah, temp is undefined. So my function. Why is this function, so the question now we should ask is, why is this function not returning a value even though clearly inside we are getting what we expect? That is fascinating. That is a really good question. Why are we not seeing what we expect here? This is a return. So we should be returning the value here. And in fact, I can prove that real quick. Okay, putting another console log right here. Yeah, see, returning version 4. Okay, so I've done something very silly here, and I don't know what I've done. Actually, let's just comment this out for now. So this is claiming it returns. So what have I done wrong? Yeah, this is very strange. I don't understand why. So this should be returning an integer, or it should be basically recursively calling itself. So why on earth is this not working? Okay, I think they've added a debugger capability, so let's actually run the debugger and see what's going here. So what I'm going to do is I'm going to put a breakpoint right here, and then we're going to debug. All right. All right, so we see n is 5, and these are our variables, so I believe what is stepping? Okay, so let's do this. Okay, so I need to put another breakpoint here. So what we want to do is put a breakpoint here, and then we want a breakpoint here. So I don't know if you've used breakpoints before. Breakpoints are basically ways to pause in the execution of the code and kind of see what's happening each step of the way as you actually run through the code itself. But let's debug again. All right, so we're going to let it execute here. Come on. All right, so why is it usually what you see here is that when you're running a debugger, you will, and I don't know how to shrink this window down, which is kind of frustrating. You would typically see like an arrow, horizontal arrow, and that horizontal arrow tells you where in the code execution you are. So, but let's just do step. Okay, there we go. So it highlights red. Okay, so you can see here, this line is highlighted red, which means that it found it. So n is 4, is bad was true, but the previous version was also was false. So that means we're good to go in this case. So we then step, oops, come on. So we step again. And so now we're at this value right here. And usually in most other IDEs, you'd be able to hover over this value. Shrink down the light arrow on the far. Are you sure? I think that's just a collapse. Unless I'm missing it. Yeah, I didn't want to collapse, so I just wanted to make it a little shorter, but No, I gotcha. No, because I'm trying to see the debugger right now as I do this, but it's okay. What I wanted to do, what I want to see is what temp is. Let's see if that gets it. So yeah, it's undefined right here. So that's where I'm stuck right now, is I don't understand why assigning this to the return of this is not resulting in a value, because this is a recursive function that calls itself until it finally gets an answer, and then it dumps the answer. But maybe, let's go back to what we were doing before. So I'm gonna stop debugging. I'm gonna push this aside for a sec, because this is technically doing a return. So maybe I'm overthinking it, and I just literally need to. I really think you're supposed to return that function. I'm like almost certain you're supposed to return this. I should just be able to return this and get the right answer I expect. Yeah, I don't know why it's not working. Okay, so I think the code is correct. I just don't know, well, the code is not correct, obviously, but I think this logic is good because we're getting 4 here. The problem is I just don't understand why I'm not getting the version I expect. But maybe I've misread the problem. No, it returns the first bad version, so it's supposed to be an integer. Okay, so in this case, when you're kind of working through a problem, after about 30 minutes, you got to stop and kind of let's look at some solutions and kind of see where we differed from the solution. So in Leetcode, you can kind of go to discussion and you go to JavaScript. So I'm going to select the JavaScript solution. Typically you want to find one that's upvoted a lot. So let's kind of look here. Okay, so this is a divide and conquer approach where you basically are having it each time. And actually, you know, it's funny. I talked about this earlier in the stream. This is a right-left pointer solution. So they completely threw away. Yeah. Okay. I'm thinking real quick. Okay, so let's look at how this is doing. So there's a left and a right pointer. While right and left is less than 1, like I said, is while they're basically the 2 pointers of the first and end version of the list are not one apart. So this is actually using binary search. That's what this is. This is binary search right here. So this is having the problem each time. If bad version is mid, right, equals mid. Okay, so and the while loop is what's executing the iteration. Okay, so I can code something a little better than this. That solution is fine. It's not quite what I was looking for, but let me look at some more of these. Okay. Okay, so let's look at this one. Let bad, while the version is bad, so basically while you're getting back a bad version, you go back a previous version, and then as soon as it's not the previous version, then return bad version. But that's basically what I did. So why does my version not work? Interesting. Okay, that's too much code. I can tell you that's too much code. This algorithm is actually not that complicated, so it should require less code than that. Yeah. Oh. Yeah. You know, that's actually not. Well, we can try that real quick, right? Let's try that real quick. That's a good question. I see what you're saying, because this is JavaScript and what is scope closure? Maybe. Let's think about that a second. So technically, if this, but the problem is from a scope, from parent scope, that's passing in. That should be okay. Both of your solutions you looked at had custom function names. Yeah. Return. Because like the thing is, realistically, I don't need to return a function. Like now that I think about it, I don't need this and I don't need this, right? What I really need, and if we just collapse this real quick, like at the end of the day, this is kind of the first class function, right? Which will always give you the same answer with no side effects. But yeah, no, I'm sorry, I totally get your name. Your point. But what I'm thinking is, actually, all I have to do is call this function, and then eventually it'll be right. Now I'm curious if that actually will work. Oops. N is not defined. Okay, yeah. So remember how I told you that it might be by the shape of how the test runner works? It's expecting it to return a function. Okay, so we can't do that. That's annoying. It's very annoying, actually. Add custom function. Outputting n. But I think this is okay, because at the end of the day, this is just a value being returned from the function, right? Like, it shouldn't actually matter. Yeah, let's go back and look at them again. Let's just take a quick look at it again. Let's see. Okay, you know what? Let's for fun, Whipple. Let's do what you're suggesting, just for fun. I'll define a new variable called previous version and set it to n-1. So if we do that, which I think is fine because it's a little bit more descriptive than n-1, which is a little harder to understand what this is. This is actually probably a little better because you know by inspection that what I'm talking about is the previous. But no, that doesn't solve the one. Well, all right. I don't think this will do anything, but let's just do this real quick. No, okay. Didn't think so. All right, so yeah, let's go back to discussion real quick and let's look at JavaScript again. I wish there's a way to sort these by. I wish there was a way to sort these. Okay, let me look at one of these real quick. So, you know, it's interesting I'm noticing is in a lot of these solutions, they throw away the fact that it returns another function. Oh, wait a minute. Did I misunderstand the problem entirely? Wait a minute. Am I supposed to implement is bad version? No, you were given an API, so why are they... some people have very confusing solutions. Let's see real quick. Let's go back and look at this version by Aeon95. Yeah, so see what this person did was they just literally threw away all that code and then they just wrote a singleton function that doesn't have a bunch of like closures, which I could do. Yeah. Okay, so I tell you what, let's simplify this. You're gonna be shocked. I'm gonna rewrite this code a different way. So let me see if this works. I'm curious if this works. I wonder if it'll allow me to do this. So this is just a quick check to see whether if I pass it in this way, I actually get n. Your output was... Okay, so what did that just do? Okay, I'm very confused at what this thing is doing. So I was expecting in this case for this to be 5, but that was not 5. It's saying I returned 1, right? Because the output was 1. So why did it think I wanted the number 1 here in this case? Oh, this is very frustrating. I feel like I'm fighting this rather than the actual algorithm at this point, which is a little frustrating. Okay. All right. Fine. Okay. Let's solve this. So what I'm going to do is I'm going to reset this real quick, which I know breaks my heart a little bit, but let's reset this. And then what we're going to do is we're going to treat this as a solution function. So let's do binary search. Yeah, it's possible it basically just exactly. It's possible that it just calls it 5 times and then it gets to 1 and it's like, hey, I hit the bottom of the range, so I'm done. So yeah, that's what I think is happening. I agree with you. So let's just do this as a binary search problem. So if I did this as a binary search problem, what I would do is I would define two points, which would be let start is equal to 1, because we know the minimum version possible is version 1. And then let end, which would be the last version, would be the most recent version. In this case would be n, right? And then we need something to loop to do the iterative, or not the iterative step, but basically to kind of run a loop until a condition is. So in this case, we kind of already saw the answer to this, but basically what we're looking for is we want to narrow in until these 2 pointers we're using in the list are within 1 of each other. So we can do that by basically saying while end minus start is equal to 1. So once they're within 1 of each other, so like, let's say the bad version is 4 and the good version is 3. Once that's the difference between those two is 1. So once they're within 1 of each other, we know that basically the end, which is the second pointer, and I know in reverse I should be doing it this way, that's the bad version we're looking for. So let's go ahead and start this loop. So the first check we're going to do, let me put this other squiggly right here as I call them. So now we need to compute the middle, which is what you were talking about earlier. So the middle in this case is going to be just an average. So it's going to be, and we need to do math.floor. I'll explain why we need to do that in a second. Math.floor of start plus end divided by 2. Okay, so the math.floor, in case you're unaware, math.floor basic, and it's just like a floor in math. It basically means you're going to take the lowest. If you're between two numbers like 4 and 5, you're basically going to take the lower of the two. In this case would be 4. And the reason why we floor it is that there are no partial versions. There's no version 3.5 in this case or version 4.5. Versions are whole numbers. So we need to make sure when we're iterating, we always get a whole number. So the floor basically ensures that we always have a whole number. So now that we have the middle of the 2 points, we're looking in the middle list, what we want to see is if is bad version. So we're going to call our API, and what we're going to ask ourselves is the bad version at the middle? Okay, so if the one we're at is a bad version, then what we're going to do, okay, so then what would we want to do in this case? If we know that this version is bad, we need to look to the left and basically try to find, so I guess the first case, like let's just go with the naive solution here in this point. So if is bad version middle, but it's not a bad version, basically the one right to the left of it is not bad, then, so in this case, we can actually return true, but that doesn't seem to, that really doesn't go by binary search. I don't want to do it that way. What I would expect to happen here is if it's a bad version, then that means we need to keep looking left. So what I would do in this case is I would say middle, end. So basically, we know that in the middle, this version is still bad, so that means the end of the list, we need to pull it to the middle, essentially, because we found it. So in this case, end is equal to middle. So now our range went from 1 to n to 1 to middle. So we have the versions we were looking for in this case. Otherwise, if it's not a bad version, so we found a good version, then that means the list is no longer 1 to end, it's middle to end instead. So we basically are looking at the right side rather than left side, so we'd have the problem. So in this case, start is equal to middle, okay? So these are the 2 conditions, and basically we're gonna keep going till they're 1 apart. Once they're 1 apart and this loop basically discontinues, at this point we know that the first bad version is going to be the end, because the end is the one slightly, so start will be the last good, and end will be the first bad, and so we will return end in this case. And I think this actually will work. Let's run the code. Okay, so I am off by 1, so I output 5 and exceed 4. So let's think about what I did wrong here. Oh, not equal to 1. While it's, I'm so sorry, this is me getting tired because I've been doing this for 30 minutes. We basically want to keep looping in this case, I believe we want it to be less than 2, but there's a way to think about this. Shoot. In this case, we want to keep looping until, well, start. Oh, is greater than 1. So basically, while the pointers are more than 1 apart, keep looping through the loop. So if we do, yep, and that works. So you'll see, sorry, it only took me 15 minutes for a simple problem, but again, that's why I'm here, and I appreciate the chat helping me out here to kind of think through this. Basically, the solution that we've implemented here is that 5 minus 4, in this case, 5 minus 1, because the start in this case initializes to 1, and end initializes to 5. So 5 minus 1 is 4, so the while condition is true, so we keep going. And then the middle is going to be 5 plus 1, which is 6, divided by 2 is 3. So the first version we're checking as bad in this case is version 3. So if 3 is bad, we know that, okay, the first candidate to be bad that's closest to the first bad version is now the middle. So instead of starting at the end, we take the end and we move it to the middle. So now, and let me just show what that would mean like from a program perspective. Instead of 1, 2, 3, 4, 5, after that first check, we know that the range of numbers we're looking for the range of versions we're looking at is now just 1, 2, 3. So we've, again, cut the space in half. So then, after this, we're going to run the while loop again. So while end is less than start, so start in this case is going to be 1, and end is going to be 3. So 3 minus 1 is 2, which is greater than 1. So yes, we keep going. So is bad for, so then we have to calculate the middle. So 3 plus 1 is 4, divided by 2 is 2. So that means in this case, we're checking we're going to be checking version 2. So is 2 a bad version? And we know for a fact that 2 is not, I'm sorry, I think I did this backwards. I so apologize. Did I do this backwards? Hold on. Did I mess up my explanation? Let me make sure I'm explaining this correctly. Yeah, the end is the middle. The middle in this case would have been 3. Yeah, that's correct. So we say, in this case, is 3 a bad version? And the answer is no. So the start, I feel like I've done something wrong. What have I done wrong, everyone? I've done something wrong. What have I done wrong, everyone, in my explanation? Five plus 1 is 6, divided by 2 is 3. Is bad version 3? Oh, I'm so silly. I'm so sorry, everyone. I'm so sorry. No. I'm backwards. All right, let me start over again. Let's start over again. So it's going to be 1, 2, 3, 4, 5 initially, correct? Yeah. So it's 1, 2, 3, 4, 5, right? So we hit the condition 5 minus, and so we start is 1 and end is 5. So 5 minus 1 is 4, which is greater than 1. So we're gonna start looping. The middle is going to be 1 plus 5, which is 6 divided by 2 is 3. So is 3 a bad version? No. We know 3 is a good version because the first bad version is 4. So it's not this one that gets hit, it's this one that gets hit. So the start now is the middle. So what does that mean? The array now looks like this. So now we know that the solution is somewhere between versions 3, 4, and 5. So we start the loop again. So 5 minus 3, n minus start, 5 minus 3 is 2, which is greater than 1. So now we're going to loop again. So now we have to calculate the new middle. So 3 plus 5 is 8 divided by 2 is 4. So the middle for this iteration of the loop is 4. So is bad version middle? Yes, the number 4 is bad, and we know that because from the example, bad is 4. So this condition will hit this time. So now the end is going to equal to 4. So what does that do to our list of numbers? It eliminates this. So now we've just got numbers 3 and 4. Now we're going to go back through the loop again. So while end minus start is greater than 1, well, 4 minus 3 is 0. So this is false. So what does that mean? We fall out of this loop. Then if you look at our function, at this point, we return end. Well, what is end in this case? It's 4. So that's how we get the answer. And that's how the binary search works. And as you can see visually, we just basically threw away half of the solutions each time until we found the condition we wanted. So I'm fairly confident at this point this will pass the full test suite because I believe this is a valid solution. So let's go ahead and submit and see if the rest of the test suite runs as expected. So we're going to judge, and we got a wrong answer. Wow, I shouldn't have been so confident, huh? All right, so let's look at the test case that failed. So the test case that failed, input 2, 1, we said it was version 2, but it expected version 1. So okay, let's look to see what's going on here in this case. So there's 2 versions, and it's saying the first version is the one that's bad. So let's talk through and kind of figure out what's going on. Okay, so I see why this is a problem. If you only have 2 versions, then the start and the end are always going to be one apart, correct? This is actually a corner I should have thought through. So if you only have 2 versions, then this condition is never going to run. So what do we need to do in this case? Yes, that's exactly correct. 2 is fed through instantly, 2 minus 1 is 1. That's correct. So the loop never runs. So a way to kind of, a way to cheat, and this is actually okay. This is, I think, let's think about how there's 2 ways to do it. We can either add another logic condition before the loop that essentially handles this, or we could think about how to modify our while loop to handle a condition where the length is already 2. Basically, there are only 2 versions. So let's think a second if we can modify the conditions of our loop to handle this. And so let's think through this a second. So the condition that we want to affect is this one right here, which is the while loop. So let's think about this a second. So if the end is 2, so if there's 2, which means the version of end is 2, and the start is 1, how can I Well, I could do it another way, right? I could actually just have them overlap and then just basically pick one of them. That is also an option as well. But let's think about that a second. Let's think about seeing if we can do what. I'm drawing a blank on the term, but what's the loop where it performs the loop once before it checks the while? Blank on the term, but what's the loop where it performs the loop? What's the loop before where it performs? What's the loop before it checks the while? Yeah, I'm trying to think about what you mean. Hold on a second, I'm trying to think it through. Well, so in this case, the first loop in this, it's not really a loop per se, but what it's going to do, so this return right here, this is the first, this is the parentmost scope. Oh, well, the things checking the condition would be, in this case, the if and else statements. But yeah, what I was trying to allude to earlier is you can actually do something like this. If n is 1, so if there's only one version, then guess what? N is the bad version, right? So the second base case you could actually, so this is a way to do it. So you could say if there's only one version, then it must be the first bad version, so return it. In fact, that's an optimization, and that's probably something we should do. So the second optimization is that if n, actually no, I can actually be more clever than this. So check this out. You want to see something kind of crazy? Here's, I'll show you. I have a solution, and you can tell me if it makes sense. So if n is less than or equal to 2, so basically if there are 2 versions, what I can tell you is that the bad version is always 1. Now, do you understand why that works? I'm going to give you like 10 seconds, and then I'll explain why it works this way. Actually, I'm sorry. I'm being too clever. I'm being too clever. Let me back up. It has to be 2 lines, but I'll explain the logic in a second. Okay. So let's explain this hack, and then we'll go back into the discussions and kind of see where I messed up. I think the answer might be, I think this might actually work, but let's explain this one approach first. So if there's one bad version, then we know the first bad version is itself because there's only one version. If there are only 2 versions, then we know that, actually no, this is not true, is it? Because theoretically, both versions, you could have 2 bad versions at the same time, right? Because even the initial version might be bad. So the only base condition you can actually have is this one right here. That's the only true base condition, because in the other case, you don't know whether the first version and the second version are both bad. So only this works. Let's see what happens if I do this. Let's kind of rock through this. Let's talk through this one and see whether this actually works the way we expect. Let's go back to submissions real quick. Okay, so let's kind of step through the inputs and see like whether we get the solution that we expect. So if the length is 2, obviously that's not true. We skip line 24. Now let's go to line 26. If end minus start is greater than or equal to 1. So in this case, 2 minus 1 is greater than or equal to 1. So that's still true. They're within 1 of each other. Now we're going to run the loop. So the difference is that we're okay with it being within 1 now. So let's calculate the middle. 2 plus 1. So in this case, 2 plus 1 is 3 divided by 2 is 1.5. But the floor of 1.5 is going to be 1. So we're going to have a 1. So now we're going to say, hey, is version 1 the bad version? Now in this case, we know that the answer is yes, it is the bad version. It's the, let me think about that. So this is the number of entries, and then the bad version is 1. So the answer is this is true. So if this is true, so if 1 is the bad version, then we're initially at 1, 2, and now basically, I'm going to show it as a list of one item of 1, but really what's happening here is start and end are both pointing to 1, correct? So we come back to the loop. N minus start is greater than or equal to 1. Well, in this case, it's 1 minus 1, which is 0. So we fall out of this loop and we return 1. Actually, this might work. This might actually solve this corner case. So let's erase this code and let's go ahead and run the standard solution. Actually, let's go through the 5-4 scenario just to make sure that this will work. And if this works, then I think we're okay. So 5 minus 4 is greater than, or sorry, 5 minus 1 is greater than 4. So 5 plus 1 is 6 divided by 2 is 3. Bad version is 3. Yeah, that's what I'm trying to figure out right now. That's exactly correct. I'm trying to figure out if this will break, because the problem is I get to 3 and 4 and then it's going to run again. So it'll run one extra time, and that one extra time is basically to then make the pointers come to the same point. But let's run through it logically. I agree. All right, so let's just make a dummy array. 1, 2, 3, 4, 5. So we were at 3. So is 3 a bad version? The answer we know is no, it's not. So start equals middle. So in this case, it becomes this, which is the same as our previous solution that we had. So now we run through it again. There's still 5 minus 3 is 2, so we still run the loop. So 3 plus 5 is 8, divided by 2 is 4. Again, no different than our previous solution. Is 4 a bad version? The answer is yes. So now the end becomes the middle. So like you were just saying in the chat, yeah, we're now at 3, 4. So now we go again. N minus start is greater than or equal to 1. Yes, because 4 minus 3 is 1. So now we're going to run the loop one additional time. So 4 plus 3 is 7. Divided by 2 is 3.5. Floored is 3. So is 3 a bad version? The answer is no, because we know that 4 is the first bad version. So we're going to fall to this case. So in this case, start is equal to middle, and I think we're now in an infinite loop, right? I think we're in an infinite loop because we were at 4, right? So 4 plus 3 is 7 divided 2, 3.5 is to 3. 3 is not the bad version. Oh, no, I'm sorry. I'm misspeaking it. Let's do it again one more time. So 4 plus 3 is 7 divided by 2 is 3.5, which is 3. So middle is currently 3. Is bad version 3? No, it's not. We know 3 is good. So we go to this. So then the start becomes 3. Yep, it's an infinite loop. Okay, so darn you corners. Yeah, it's an infinite loop. That's correct. Okay, so all right, now let's go look. At this point, we're an hour in. Let's go see how this was solved. But we were on the right track. I think we were on the track of what was expected. No, that's clever. This is not binary search. Why was that binary search? That wasn't, by the way, that wasn't binary search. That was iterative, which is what you were talking about earlier. Oh. Okay, I understand. All right, I'll explain the solution now. Okay. Yeah. Okay, I'll explain. Okay, so the thing we missed, is for this condition, you need to step one additional over. So let me explain why this works, and I'm pretty certain this is going to work. I'm going to submit it. Oh, maybe I'm wrong. I thought this was going to work. Did I forget to revert something else? I was expecting that to work because the idea is that you basically shift this up by one. So remember we were talking about, oh, what if we do this now? Yep, that worked. That was it. Yep. All right, so let's walk through it. So we solved the problem now because we've succeeded through the test case, but let's walk through it to understand what we did together on this one. All right, so let's start with the 5-4 case again, because this should be able to explain what's going on here. And let's kind of talk through what we did here. So we start with 1, 2, 3, 4, 5. Bad version is 4. So start is 1, end is 5. 5 minus 1 is 4. So this condition is true. The middle is 5 plus 1 is 6 divided by 2, which is 3. So then we say, is 3 a bad version? Actually, plus 1. Oh, yeah. Let me show you. We're going to walk through it real quick. Let's go through it together. So let's start again with 1, 2, 3, 4, 5. So while n minus start is greater than or equal to 1, so which is true because 5 minus 1 is 4. The middle is 5 plus 1. 5 plus 1 is 6. Divided by 2 is 3. So is 3 the bad version? The answer is no. The first bad version is 4. So we hit this condition. So start is going to equal middle plus 1. Now why did we do middle plus 1 here? So that's half the question you're asking, and then we'll explain why I had to do the greater than or equal. There's another way to do this, but this is one way of doing it. So what did we just say about 3? 3 is not a bad version, correct? It's a good version because we just ran it through this first condition, is bad version middle, so we know it's good. 3 can never be the solution, right? Because we're looking for the first bad version, not the first good version. So there's no point in returning the middle because we know that middle value is already a good version. So, but what we don't know is if the one after it or the next version after it is the bad version. So we want to pass the next one after that in as the new pointer. So instead of 1, 2, 3, 4, 5, what we end up actually doing is 4, 5. So we eliminate 1, 2, and 3 because we no longer need 3 anymore. All right, so now we've reduced the scope to 4 and 5. So now we're going to hit our condition again. 5 minus 4 is greater than or equal to 1. That is true, correct? Because it's still within 1. We calculate the middle now. 5 plus floor is 9 divided by 2 is 4.5. Floored brings us to 4. So right now middle is 4. So the question is 4 a bad version? And the answer is yes, right? Because like we discussed in the solution here, bad is 4. So at this point, I now can say, okay, this is a bad version, so everything after this bad version doesn't matter because this is the lowest bad version I've found so far. So effectively what this means is now we're left with this. So start and end are now the same value. So I come back up, well, n minus start is greater than or equal to 1, well, it's 0 now. So because 4 minus 4 is 0. So we've hit the end of our loop and we return 4, which is the correct answer. So again, the key in this little subtle change we made is that when we find a good version, we don't set the start of the list to that good version, we set it to the version right after that, so one higher. And that helps us eliminate that infinite loop condition because we're no longer stuck still adding a version back to the list for the next loop that we already know is good. There's no point in looking at it again. We know that that's not going to be the answer, so we can throw that away and not have to use that in our computation. So that was it. So by applying that one fix, we now have a binary search problem. Cool. And hey, thanks so much. Honestly, I really enjoyed chatting with you on this. It was good. I should have figured this out 40 minutes ago, but I'm really rusty right now. So it was really fun to work through this together with you. And I think I'm going to cut off this session. Thanks so much to everyone who joined. I think in this case, Wibble, you're the last person here. I'll be back in tomorrow, and thanks for stopping by. Take care.